We now discuss the solution of a problem from the section Coordinate Geometry. The problem is on the circles. This question has appeared in Joint Entrance Examination Main held on 27th July 2021 in the Shift 1. The problem is, let A is equal to the set of all ordered pairs x comma y belongs to R cross R, where R is the set of all real numbers such that 2x square plus 2y square minus 2x minus 2y is equal to 1, and capital B is the set of all ordered pairs x comma y belongs to R cross R such that 4x square plus 4y square minus 16y plus 7 is equal to 0, and set C is equal to the set consisting of all ordered pairs x comma y belongs to R comma R cross R such that x square plus y square minus 4x minus 2y plus 5 is less than or equal to R square. Then the minimum value of modulus of R such that A union B is contained in C is equal to, the four options are given to us. The option 1, 1 plus root 5, option 2, 3 plus 2 root 5 by 2, option 3, 3 plus root 10 by 2, option 4, 2 plus root 10 by 2. We now discuss the solution of the problem in detail. We are given capital A, the set of all ordered pairs x comma y belongs to R cross R such that 2x square plus 2y square minus 2x minus 2y is equal to 1. Let's take this equation and divide throughout by 2. We get this and make the perfect squares, and balancing the terms we get x minus 1 by 2 whole square, and to balance that minus 1 by 4 plus y minus 1 by 2 whole square minus 1 by 4 is equal to 1 by 2, and this will imply x minus 1 by 2 whole square plus y minus 1 by 2 whole square is equal to 1 by 2 plus 1 by 4 plus 1 by 4, that is 1. What is this? This is a circle with center at the ordered pair 1 by 2 comma 1 by 2 and the radius 1. And that is, A consists of all points on the circle. Let us name that circle as C suffix A, CA, circle C related to A, circle CA with center C1 at 1 by 2 comma 1 by 2 and the radius R1 is equal to 1. Get into the second set. We are given the capital B, the set is equal to the set of all ordered pairs x comma y belongs to R cross R satisfying 4x square plus 4y square minus 16y plus 7 is equal to 0. Let's take this equation, divide throughout by 4. We get this equation. Now write down as perfect squares and balancing the terms. What we get is x square plus y minus 2 whole square, to balance that minus 4 is equal to minus 7 by 4, and send this 4 to the other side. We get x square plus y minus 2 whole square is equal to 9 by 4, that is 3 by 2 whole square. So capital B is the set of all those ordered pairs x comma y belongs to R cross R, which satisfy x square plus y minus 2 whole square is equal to 3 by 2 whole square. What is this? B consists of all points on the circle C related to B, CB, with center C2 0, 2, and the radius R2 is equal to 3 by 2. Let's get into the third set. We are given C, all ordered pairs x, y belongs to R cross R, which satisfy x square plus y square minus 4x minus 2y plus 5 is less than or equal to R square. And that equation, that inequality will now become x minus 2 whole square plus y minus 1 whole square. That is precisely the left hand side of this inequality is less than or equal to R square. So C consists of all those ordered pairs x, y belongs to R cross R, which satisfy x minus 2 whole square plus y minus 1 whole square less than or equal to R square. This time C not only consists of the points on the circle, but all those points which lie inside the circle also are also included. That is, C consists of all points inside and on the circle C suffix C, inside and on the circle C suffix C, with the center C3 at 2, 1 and radius R. Inside and on the circle CC with the center at C3, 2, 1 and radius R. Let's now summarize what we have done. Capital A is the set of all points on the circle CA with center C1 with coordinates 1 by 2, 1 by 2 and radius R1 is equal to 1. Capital B, the set of all points of the circle CB with center at C2, 0, 2 and radius R2 is equal to 3 by 2. Capital C, the set of all points inside and on the circle CC with the center C3 with coordinates 2, 1 and radius R. Now, we observe C2, C1, the distance between C2, C1 and C2 is 0, 2, C1 is 1 by 2, 1 by 2, the distance formula we have used, and that is equal to under the square root of 5 by 2, and this is greater than R1, where R1 is 1. Yes, root of 5 by 2 is greater than 1, and root of 5 by 2 is also greater than R2 is equal to 3 by 2. So, the distance between the center C2 and C1 is greater than R1 and is greater than R2 means what? It means the circles CA and CB intersect. Further, the distance between C3 and C1, C3 is 2, 1, C1 is 1 by 2, 1 by 2, use the formula, and we will get again root of 5 by 2, which is bigger than R1. And C3, C2, C3 2, 1, C2 is 0, 2, use the formula, you will get root 5 is greater than R2, that is 3 by 2. So what does it mean? What does it mean? So C3 lies outside both the circles CA and CB. These are the two, two properties what we have seen here. Now, C2 is greater than R1 and C2, C1 is greater than R1, is also greater than R2. Therefore, CA and CB intersect. So, this is what will happen. CA and CB intersect. And further, C3, C1 is greater than R1, C3, C2 is greater than R2. Therefore, C3 lies outside CA and CB. So, C3 lies here. So, that is the pictorial representation roughly. Finally, so that is the situation. what we have, and extend C3 C1 to cut the circle CA at P. So this is the one. Now if you want C3P, the distance C3P is equal to C3C1 plus C1P. C3C1 plus C1P is the radius R1 of the circle CA. So C3C1 plus R1. C3C1 is under the square root of 5 by 2. R1 is plus 1. Now join C3, C2, extend it, and it cuts the circle CB at Q. C3, C2 such that it cuts CB at Q. So CB at Q. Now if you want C3 to Q distance is equal to C3 to C2 plus C2 to Q, C2Q. That is C3 C2 plus R2, and C3 C2 is root 5, R2 is plus 3 by 2. So that's the one. And if you want to draw a circle with center C3 and radius R in such a manner that A union B, this is A and this is B, A union B is contained in C, your radius must be bigger than C3 to Q in this situation. But this we will give, no, we will not look at the picture and talk about, but in general what we can do is, you recall CC, that is the circle related to C, is a circle with center at C3 with coordinates 2, 1 and a radius R. So that's the one. Now if R is greater than or equal to maximum of C3P and C3Q, then A is contained in C, capital C, and B is also contained, and thereby A union B is contained in C. So that is this is the picture. So this is the picture. So if R is bigger than the maximum of C3Q and C3P, then A union B is contained in C, and that is R is greater than the maximum of C3P is C3C1 plus R1, C3Q is C3C2 plus R2, and that is the maximum of root of 5 by 2 plus 1 comma root of 5 plus 3 by 2. The maximum of these two is root of 5 plus 3 by 2. And that is R is greater than or equal to root 5 plus 3 by 2. Then A union B is contained in C. We want to find the minimum value. The minimum value of R is, it should be at least equal. That is R is equal to root 5 plus 3 by 2. That is equal to, taking the LCM, we will get 3 plus 2 root 5 by 2. Let's look at our options. And our answer appears against option 2. And hence, our final answer is option 2. And in this, I have tried to give a general attacking method of this problem. Now, I am not taken away by the diagram. In general, what we can do is, of course, we can also draw a suitable diagram and can get some inference from that also. But in this, I have tried, to give a general method of attacking this problem. I hope that you have understood the solution of this problem, and I am sure you liked the solution of the problem, and go on working out some more problems on these lines. And I wish you all the best. Thank you.